All right, so we've done this a bunch of times in class, but we'll go ahead and do this again. Um, we're going to add one piece that I haven't done so far in class, which is to go ahead and write the domain of the function. But we know that if we're going to graph a rational function by hand, we need to think about and consider all of our intercepts. Oh, my Jamboard is super laggy. All of our intercepts and all of our asymptotes. So intercepts, we got x and we got y. So we have two that we need to find. Our x-intercept, which is our 0, which is our root, which is our, have a bunch of different ways to talk about. So our x-intercepts are zeros. Those are what we're going to have. Ooh. Ugh, I'm frozen again. I rebooted just to verify. Nope. All right, x-intercepts or roots. Not roots, I meant to write zeros here. See what happens when my computer just decides to have all the screens go blank at once. Our x-intercepts are our zeros. We're going to find those by setting our numerator equal to 0. So in this case, our numerator is x squared minus 1. In fact, we may start this off immediately by going, hey, I know for both my x-intercepts and my vertical asymptotes, I need a factored function. So I may take a moment at the beginning of this whole thing and be like, okay, I see in the numerator my difference of squares. That's just going to be x plus 1, x minus 1. I see in the denominator at least a GCF. I can take out an x from everything, leaving me with an x squared plus 9x plus 14x. Oh, it's not 14x. There's only an x. There's no x left. I just factored that out. And then I have to go, okay, what multiplies to 14 and adds to, 2 and 7. So let me break this down again. Turns out that this is x times x plus 7 times x plus 2. So I've got my factored version. This is the exact same function, just written out factored instead of multiplied out. So in terms of setting my numerator equal to 0, I'm taking this x plus 1, x minus 1, and setting it equal to 0. So here we have x is either equal to 1, or I guess I should do them in order. X is equal to negative 1, or x is equal to 1. And technically, if I'm going to be good about it, I should give out intercepts because they are points as ordered pairs. So if this was a question on a test, I should write negative 1 comma 0 and 1 comma 0 as my intercept, or as my intercept, as opposed to writing just x is equal to negative 1, x is equal to 1, because that doesn't convey the whole bit of information. All right, so that's my x-intercepts. That's all done. Let me go ahead and just give us some like grouping to keep all that together. All right, so then we move on and we need to find our y-intercept. And so y-intercept is, I think, easier from the multiplied out version of our function if we have it. Not terrible either way. We find our y-intercept by setting x equal to 0. This is just what happens when we have plug in 0. Looks like a y almost. The reason I like the unfactored form is that every term that's not constant, it will just become 0. So we'll get a negative 1 over 0, and we go, oops, there isn't one, right? Because we got something out that's not a real number. So there is no y-intercept. We would write none on the Desmos activity. And then we move to our asymptotes. So for our asymptotes, let's start first with our vertical asymptotes because we've already, gone ahead and factored the bottom. We know anything that makes our denominator equal to 0 is something that results in what we saw here, an eq, a problem. So we know x is equal to 0 is one of those vertical asymptotes. And this is actually correct. We need x is equal to 0. That is the equation for a vertical line. We can also see there are two more solutions. X is equal to negative 7, x is equal to negative 2. Those are our asymptotes, our vertical asymptotes for our function. All right. All right, the last thing that we need to graph our function is our color I have not used. I guess I'll stick with red and I'll just finish in yellow. The last thing we need is our horizontal asymptote. Ugh, I always forget this. Horizontal asymptote. So horizontal is about looking at the degree of our two functions and thinking about what happens with the end behavior, right? As we go to infinity for x, what's going to happen? So we are looking, when we do these questions, at our leading terms. So the degree is 2 over degree 3, which means the bottom is going to infinity much faster than the top. And when we divide by something really freaking big, that means this thing is approaching 0. And that's going to happen anytime the degree of our numerator is less than the degree of our denominator. That's the y it happens. Anytime this happens, we get out a horizontal asymptote of y is equal to 0. So that's our last piece of this. So let me, it's doing its dumb thing and it's going to freeze for a second again. Okay, I like that. So now we got this last piece. And I didn't write 0 because my thing was frozen. So we'll bring that back, 0. So now we can bring that all together into one last beautiful graph, right? Into our graph. So our graph, we know we have zeros. I'll go ahead and start with those. Our x-intercepts at -1 and 1. We know that we don't have a y-intercept. That's where we had one of our 3 vertical asymptotes. We got one here. We got one over at -7. And we got one at -2. So those are all of our asymptotes. In fact, I'm going to go ahead and give them a cute little highlighter so that they're even more obvious. And then we also have our horizontal asymptote, which is at y is equal to 0. So we know no matter what for our little function, it's going off towards 0 at the ends, whether we don't know if it's from the top or from the bottom. And we also have these 2 places where we are going to cross our x-axes. And we know we are crossing, both of these zeros we're crossing because they're both multiplicity 1. So this is where you could start by trying to sketch this thing. It's going to be kind of a pain in the butt, and you might want a sign table. This is where at least we need one more point somewhere to give us some guidance as to what the heck is going on. I say this because right now I don't know if this does this or it has a cute, I don't really know how I'm going to do all of this. I know, based on what we talked about today in class, that each of these also have multiplicity, right? Our vertical asymptotes have an odd multiplicity, which means that they will have whatever that behavior is in terms of my output going to infinity. If it's going to infinity on one side, it's going to be going to negative infinity on the other. But I need to know something to start with. So I could plug in a number, I can make a sign table. I might just think about what happens over here. Like what if I was to plug in 2? If I was to plug in the number 2, this would be positive, this would be positive, 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 and positive. So 2 is above. All right, that gives me some information because if I'm above at 2, I have to come below, I have to come and cross at 1, right? We know that. And if I'm crossing, I can't cross again. I'm not bouncing before this asymptote, so I have to go down here, right? I also know that as I move to the right, I've got to approach 0. So at some point, this has got to come back down. Obviously, I'm not getting like the best graph of my thing, but there's got to be some local maximum, some turning point somewhere beyond 1 on that right side in that quadrant 1. There is something going on in terms of a critical value. All right, now that I know that this right side went to negative infinity, right, as x approached 0 from the right, we went to negative infinity. That means this has got to be positive infinity because it had that multiplicity where we had that change in sign. And of course, we could try plugging in numbers. I think that's a waste of time, especially because in this case, 0 is an asymptote, -2 is an asymptote, and -1 is a 0. So if you were going to plug in, you got to plug in fractions. And oh my God, I do not want to plug in fractions. So I really like knowing that the multiplicity uh, of a asymptote tells us sort of the same thing about switching what's happening. So no matter what, there's something like that going on, kind of like a little baby cubic or like a tangent chunk kind of going on in there. And then again, multiplicity is odd on this asymptote, so I got to start off here at infinity. But look, I can't cross, right? This is the great question Delise asked in class today. I cannot cross that x-axis because I have no zeros. So I must, as I'm coming down, come back up and do this. It's the only way it happens is that I did not cross that axis. I had to have come up. I must have a local minimum, a critical value somewhere in that region. And then again, we change sign. So we're over here in terms of our infinities, our asymptotes behavior, and we got to come up and approach our zero. So there is a very, very rough sketch of this graph. I'm going to pause, put this in Desmos, and then see what we have. Do we feel like geniuses or what? Look, is this graph, obviously the shape is slightly different. You can see the little tangenty cubicy section between 0 and -2 is a lot more intense than what we drew. We don't see that the is such an obvious critical value is what we had when we plugged in 2. And there's a kind of a weird shape to the parabole piece that's over there. But in general, we've got a lot of great pieces, and we could use something like this to think about an answer to a question about a rational inequality, right? We can see, when is this above the x-axis? Oh, well, if that was the question, like a greater than or equal to 0, we would look at this section and this section only. Oh, and this section. So we'd have these 3 sections of the graph. But, right, this is just so fun, in my opinion, to do by hand. But again, a little bit antiquated in terms of what we're doing. So x-intercepts, straightforward, right? The worst case that could happen in terms of x-intercepts is we get a function in the numerator that's not factorable, and we got to use the quadratic formula or something. That doesn't happen in this cute mathy land where everything works out pretty. Y-intercept, super straightforward, plug in 0. Worst case, you get what I had here, which was there wasn't a y-intercept, and instead we had an asymptote. And then the vertical asymptotes, again, pretty straightforward. The only thing that we really need to spend maybe another video on is horizontal asymptotes, and breaking down the 3 possibilities, or really 4, like all the possibilities that could happen when it comes to end behavior of a rational function.